Hello there, science fans. Today we're going to talk about a fascinating concept in chemistry called the screening effect, or the shielding effect. And what better way to understand it than with a relatable family analogy? Imagine a sunny afternoon at the park. I'm enjoying my playtime, but my mom has called me back home for dinner. Now I'm not quite ready to leave yet. Luckily, I've got my family here with me, and they're about to demonstrate the shielding effect in action. In an atom, the nucleus, like my mom, exerts a strong attraction on the electrons, which are like the children. The closer an electron is to the nucleus, the stronger the attraction. But just like having protective family members, electrons in the inner shells can shield the outer electrons from the full force of the nucleus's pull. My grandfather, being the closest to me, is the first line of defense. He's like the s orbital in an atom, which is closest to the nucleus. The s orbital is like a protective barrier around me, shielding me from some of my mom's calls. Just like my grandfather, the s orbital electrons experience the strongest attraction from the nucleus, but they also provide the most shielding to the outer electrons. Next, we have my dad, representing the p orbital, and my brother, representing the d orbital. They stand between me and my grandfather, adding more layers of protection from my mom's insistent calls. While not as close to the nucleus as the s orbital, the p and d orbitals still play a significant role in shielding. They are like extra layers of clothing on a cold day, each layer reducing the chill. So, just like my family protecting me from my mom's calls, the inner electrons shield the outer electrons from the full force of the nucleus's attraction. This shielding effect is what we call the screening effect in chemistry. The order of shielding strength, just like the protectiveness of my family members, follows a specific pattern. Spotty F. This means s orbitals provide the most shielding, followed by p, then d, and lastly f orbitals. And there you have it, the screening effect explained through a fun family day at the park. Remember, just like a family, electrons look out for each other, reducing the effective pull from the nucleus and influencing how atoms behave.